Okay. Happy Saturday. Let's see. Um, I have some time, a little bit more time today. So let's just try to see how much we can get done. Again, uh, these sessions are just me doing stuff on front of the computer, so I actually don't mentally keep track where we actually leave off. I also don't really look back at some of these videos. So I think where we left off yesterday, and it's only been yesterday, is I think we're just gonna learn how to write functions. It looks like from the page we're at here. Let's see. Yeah, it looks like it. So I think at this point we're starting to be able to create more complex programs. Really, it's just like writing. I think writing a good C program mostly is you can get away with just knowing how to call functions, write functions, loops and conditions, and so on. So yeah. Uh, oh, it looks like this is actually just a detour. It says, before you try out your new Loop Mojo, let's go on a detour and take a quick look at functions. So this may just be like a quick stop to kind of just review what functions are. And I personally don't think there's like much to it. It just looks like any other like programming language where you define, function, you just call it, except that in C, you have to define the function um, before you actually call it, right? Like it has to be defined, right? And there is a thing where in your C file you have to define all the functions ahead of time, and then have your main function at the end. So yeah, this is the format right here. So let's read this. So far, you've had to create one function in every program you've written. The main function. Okay, so again, the function main returns an int value, and that's usually going to be like the return code, right? Either zero or a non-zero, right? In this case, a non-zero indicates an error, a zero indicates success. We also give the name of the function, and from what we remember, main is a special name of the function, right? It's like a very unique name in that um, every C program will have one, right? Um, and your function can also take in some arguments, right? In this case, your function doesn't have any arguments here, the main function. We'll change that soon, right? And then finally, you have a body, right? And the one thing to know is that for functions, you should always try to return something, right? If it's not a void type. And I'll show you some of that later. So um, pretty much all functions in C follow the same format. For example, this is a program with a custom function that gets called by main. So we have one function here called larger that takes in two arguments, right? An argument of a, which is an integer, expected to be an integer type, and an argument of b, which is also expected to be an integer type. The function body is in here, and it's just logic, right? So, here's an if statement. We check if the value in A is greater than the value in B, then we'll just return A. Otherwise, right, no curly braces. I don't like it, but let's just, go with it. Um, Otherwise, we'll just return B. So when we return from a function, right, whenever we see a return, we're going to get out of the function, right? And then the value that's returned is what's going to be the value that you can grab to assign to something else from the call, right? So yeah, the main function has an int return type. So you should include a return statement when you get to the end. But if you leave the return statement out, the code will still compile, though you may get a warning from the compiler. A C99 compliant compiler will insert a return statement for you if you forget. Use a -std99 to compile to the C99 standard. right? So like even if you don't have a return in your main function, the compiler will kind of just insert one automatically for you. Um, so the larger function, larger as in like larger function, right? This function here is slightly different from main because it takes arguments or parameters. An argument is just a local variable that gets its value from the code that calls the function. The larger function takes two arguments, a and b, and then it returns a value whichever one is larger, just like what we reviewed. So I'll just give an example here. Not the same one, but just for practice, right? We'll create a new project, functions test, right? And then we'll create a main.c. And then again, just get the reps in, just type it, all right? Get used to the syntax. So we'll include the stdio.h library, and then we'll define a main function, right? And we'll just have return 0 immediately, and that's a simple function. Let's write another function that we can call inside main that just prints hello world. So whenever we have a function that doesn't return anything, right, we can actually call it a void, right? A void type, right? Every function needs to have a type. So, it could be int, bool, not bool, int, character, long, double, float, whatever, right? And that will usually indicate what type of value will be returned back from the function call. But if you don't have any value that's going to be returned back, right, then you can actually define your function as a void type. Void means you don't want to return anything. So we can then define this function called print hello, where we simply just have a print statement saying hello world with a new line. And then, that's all there is to it, right? So we'll call this function here, right? So we'll call the print hello function inside main. So when we call this function, we should go to the print hello function here. We'll print hello world, and then we'll return 0. So let's just quickly see how that looks like in our terminal. So we'll go back here, and then we'll go to the functions test, and it will be gcc main.c -o functions test. So that's compiled. We'll see if it's compiled. It is. We'll execute the program, right? And it's kind of hard to see now with this trailing out, but let's do this. Okay, so we'll see that we actually have this hello world printed out. Okay, now remember I said that you should always define your functions, right, before you use it up down here in main. So we can't really just do this, right? We can't just like have our main be on top and then our print hello function be on the bottom, right? So we did this, we'll get an error, right? We try to compile, it says, well, error, implicit declaration of function print hello, right? So as a compiler is scanning through your code to try and put it together, it finds that you have a reference to print hello, right? This variable here, which functions are, just think of it as like variables. This reference here doesn't exist yet. You've never defined it as it's scanning, right? So it goes, whoa, I don't know what this is, okay? So I'm just not going to do anything, and that's why it quits. But if you actually define the function up here, just cut, paste, right? Then as the compiler is scanning like word for word, it would have hit this print hello at some point, right? And then when it gets down here to reference print hello to kind of compile what that would do, then it goes, oh, I know that print hello, it's up here. You've defined it somewhere already, okay? I've simplified it, but right now just think of it that way, right? There's actually two separate things to it. There's a definition of it, and then there's the implementation of it. Right now, when we write our functions, we do both the definition here, and then we also then give it the implementation, right? So you can actually define the function first at top, and then provide the implementation later somewhere down the line. All that's important is that in C, you must have had to at least define it once before already when you encounter usage of a function, right? Or any variable if you really think about it, because if you have something like this, print f %d I, you can't just do I equals, you can't do that, right? That's wrong, right? So you even get a red squiggly here saying identifier I is undefined, right? Code executes in order. So yeah. Oh, void functions. We just talked about this. Most functions in C, right, have a return value, but sometimes you might just want to create a function that has nothing useful to return. It might just do stuff rather than calculate stuff. Normally, functions always have to contain a return statement, but not if you give your function the return type void. So void is the only function where you don't have to have the explicit return. But just imagine that it does kind of. It's just this. It just looks like this. Return. It doesn't return a value, but it just return just means to get out of the function, right? And then when you return a value from a function, you're just saying, hey, get out of this function, but give back this value to the caller of the function, right? So if we had something like, for example, int get y, right? Get double of y, right? And we'll say int y here, and we'll just say return int double of doubled y times 2, right? And then we could say return doubled. When we call this function, right, get double y, right, and we'll say maybe double 7, right? The result that we get from here is actually going to be 14. But if we call it like this and we return the double of this, right, the double of whatever we pass in, we're not going to have it anywhere in memory until we actually give it an assignment. So for example, double 7 int double 7, right? And we'll print that. So that's how you can actually start to like make code a little bit more modular by separating things out. And if you need that value from a function, you can just assign it to the same type, right? So like an int function, calling it a function that returns back an int can always be assigned back to an int. So if we were to compile again, oopsie, not print, but printf. Yeah, there we go. You see how we get 14, right? We assigned 14, which was returned by get double y into this double of 7 variable. So yeah, in this case, if we try something like this, void a equals this, right? We actually get syntax error, right? Because it doesn't make sense, really, because we don't return a value. So, all right. Okay, if I create void functions, right, does that mean it can't contain a return statement? Oh yeah, you can still include a return statement, but the compiler will most likely generate a warning. Also, there's no point to including a return statement in the void function. That's true, but we did anyway. Really, why not? Because if you try to read the value of your void function, the compiler will refuse to compile your code. Just like what we had done here. We tried to say void a, right? And the compiler, of course, is not going to let this pass. So, all right. Chaining assignments. All right. Almost everything in C has a return value, and not just function calls. In fact, even things like assignments have return values. For example, if you look at the statement x equals 4, right, where it assigns the number 4 to a variable, the interesting thing is that the expression x equals 4 itself has the value that was assigned to 4. So why does that matter? It's because then you could do cool tricks like chaining the assignments together. We can do things like y is now equals to x equals to 4, where basically if we do x equals to 4, that technically returns 4, and we can then assign 4 to y. If we simplify this, we have this weird syntax here. Y equals x, which is equals to 4, right? I personally don't do this that often, but apparently the book says it is done that often. Yeah. But then again, I'm also not very good at C. I don't program it often. I just want to learn more so I can start doing that, right? So, um, yeah, I suggest you just do this for fun, right? I don't think we'll do it ourselves. Okay, so big exercise, huh? Let's try to do this instead. All right, so now that we know how to create while loops, modify the program to keep a running count of the card game. I knew it. I knew we would have to eventually do this because, right now we were just printing out. Oh, count went up, count went down. So now we're actually keeping count, like real counts. It looks like they did for us already though, but it's okay. So now that you know how to create while loops, modify the program to keep a running count of the card game. Display the count after each card and end the program if the player types X. Display an error message if the player types a bad card value, like 11 or 24. Okay, let's actually type out this template first, and then let's try to digest the problem, okay? It's better to actually see it in highlighted syntax, like this code and highlighted syntax, than like this page here, and trying to like, oh, what is this? Let's actually digest the code by just typing it first. Get that understanding by typing, and then you'll have a visual like in terms of having some syntax being highlighted, so you know what is a C keyword and what's not. So just simplifies things a little bit more. So I'm going to create a new project called cards test. No, cards 2. Okay. We'll create one called cards2. We'll create a new file, main.c. Okay. And we'll just kind of just type all of this here, and then we'll kind of comment the places where we need to like implement code at, right? So, okay. I'm ready. All right. So we'll have include, right? std stdio.h include stdlib.h, right? Then we'll define a main function. Then we'll, of course, return 0 at the end. Then we'll declare a string, right? Basically an array of characters named card underscore name. It is 3 characters long, right? So I'm guessing you have 2 valid characters, and then the last character is that null terminating character. So it's an empty string right now. So when we do it like this, where we declare a character array with some fixed length already, it's basically an empty string. So we'll define also another variable called count, initialize that to 0, and then we'll have a while loop with something. And this is a way to kind of have like a placeholder, right? Implement this. Oops. You'll get red squigglies, but ignore it. Oh, put string, enter the card name. Okay. Then we'll scan F. So we'll scan for 2 characters, it looks like, right? Into the card name array. In this case, we get an array of characters, it'll just be a string. So then after the user has put in something, right, with this call, card name will have exactly what they put in. So it's kind of just dumping all the data into the card name. We'll initialize an integer called val to be 0. And then we'll have a switch statement that will check against the card, the first letter of the card name string, basically the first element, right? We'll have a few case statements. And if that first character is a KQJ, then the value is going to be 10, right? And we'll break because we don't want weird bugs. And then we check to see if, well, what happens if the first letter of card name is A? Well, we set that to 11, right? And then what happens if it's X, right? Well, let's kind of have a comment here. It says implement this, okay? And then we'll have a default that will just do a conversion of the string right here, of the string card name to an integer, right? And it will implement more here. Okay? So that's our switch. After our switch, we do this check again. Remember the counting up, counting down, or no, count gone up, count gone down, something like that, right? And then we'll also display the current count after each input. So it's just this again, val. If val is greater than 2 and val happens to be less than 7, meaning that if the value is anywhere between 3 and 6, right, we increment count. Otherwise, if val is 10, right, we will just decrement count. And we will always want to let the user, or in this case a player, know what their count is after every input. I think %i is just a regular integer. I like d. Okay. Let's see, what's the difference? Is it %i versus, where is it? What is it? %i versus %d printf. What is the difference? Hey, it's not working. Huh? Oh, no results found. Oh, no %. How about that? Oh, this is tab search. I want not tab search. I want, how do I normal search? Oh, that's why, because I think this causes tab search. Ah, like this? Maybe? %i and %d printf difference. What's the difference between %i and %d and blah, blah, blah? Okay. Let's see. Oh, okay, so capital D is not standard. When it comes to lowercase %d and lowercase %i, there's no difference for output, okay? However, for input data, only when you're receiving input, right, in the scanf part, %i can be used for scanning hexadecimals, okay? So values that you input with 0x in front. Interesting. Okay, so no real difference. Okay, let's go back. Okay. So we have this here. The first task we need to do, right, is modify the program to keep a running count of the card game, which we have. Okay. Display the count after each card and end the program if the player types X. Okay, that's our first requirement, right? If the player types X right here, we want to end the program, right? So when we say end the program, right, we want to just basically return what? 0 or something like this, right? However, if you look at what they're giving us a hint here, it says you need to stop this loop if she enters X, right? So here, if the input happens to be X, right, then what ends up happening then we should just exit the program, meaning the while loop has to be false so we can go back down here, right? So I'm thinking, right? That card name, right? Since we have card name defined up here, we can say something like while card name at 0 is not equal, right, to X, right? We can say something like that. Or we can use a flag and then set the flag, right? So we can do several things. I personally don't like it like this, the way I'm displaying it right now, right? I kind of want to actually instead have a flag that we can flip back and forth, right? So like we can do something like this. Like if this flag is true, meaning that if we're still playing, maybe is playing, right? Then execute the while loop. So while is playing, just keep asking for the card name, right? And then see what you should assign val, and then increment and decrement the count from there, right? So a flag while is playing, right? While maybe is playing, like that, right? And then we could probably declare that as an int because flags like booleans, right, true, false, are just basically integers in C. So we go while is playing, do all of this, right? Now we have X here. If she typed X, our player, we can just say is playing, right? Is now false, right? Now when we do is playing, oh, not false, 0. Because again in C, true is non-zero, false is 0 in terms of integer, right? So now our player, right, if they while they are still playing, if they typed X, we set is playing to 0, right? And what should we do? Well, we could say break, right? We type break here. What ends up happening now is that sure, we set the flag, but code still needs to get out of the switch statement because that's what break does, right? Break will cause us to go out of here into here, and now we check for our value. Is that what we really want? I think the requirement here says display the count after each card and end the program if the player types X. So we want to end it right away, right? So I'm thinking we should use our friend the continue statement instead, right? If we use continue, well, after we set is playing is 0 and we hit continue, we actually go, we pretend that was like the last line, right? Like from yesterday. And then we go back up, right, to our loop here and we check is playing. Since that is 0 now, instead of 1, that condition actually evaluates to false. Again, in C, 0 is technically false, and then any non-zero is true. Now, since is playing, the flag is playing is 0, that's false. So this condition isn't true, and so we don't execute anything in the while loop body, right? Which is basically, if I do some brace matching, all of this. So we just return 0 right away. Okay? So I encourage some tracing here. But we need to check first to see if this is working. So that's like the requirement here. If the player is, if they've typed X, we can just set our flag to 0, right? Display an error message if the player typed a bad card, like 11 or 24. Okay, well maybe here, right? So this is where we can actually figure out what number, right? It is because we've converted the card name from a string now to an integer, right? And assigned that to val. So at this point, val can be any number. It could be like right here at this point, right? It could be like 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe 11, right? 24, whatever, right? So I think what we want, right, is if the card, is, we have what? A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, K, Q, yeah, right? So we have those cards. Invalid cards would be anything like 11 and above, right? And anything below one. I think two is the lowest card in playing cards, right? Because an ace is still A in this case per our requirement, right? So we can check here, right? And we'll display an error, and let's like return right away. We don't need to do any flags or anything. If there's an error, we can just say return one in this case, like return a non-zero, right? So we can check. Use our if skills. If, right? Val is less than 2, right? Or val is going to be greater than 10, right? We are going to say, please enter a valid card, right? And then we'll just return 1, okay? Otherwise, right, if there's no error, we can just have our break statement here, okay? So let's check that over this case, right? If the card is invalid, meaning 11 or 24, display an error and exit, right? So if I gave 2, well, val is 2, so val less than 2, that is false. Or 2 greater than 10, that is also false. So we don't execute that, we just break, and then we check and do all these things here, either increment the count or decrement and so on. Okay, if we say val is 11, like the example here, well, 11 is not less than 2. Okay, that's fine, but there's an or, so one or the other has to be true, right? So, val in this case, 11 is greater than 10, but that's not a valid card, so we print and then exit. Something like that, right? And that fulfills all our requirements for this program. We can actually test it now, right? And this would be fun to test because now we have a while loop that constantly asks for input, right? So if we were to go back one directory up, I can call it cards test 2, or no, cards 2. Cards 2. We'll compile our program. And just to change it up, I'm not going to provide output. I'm just going to use the default a.out. So, my list, I see a.out. I'm going to execute. Oh, airplane. Okay, so I'm going to execute a.out. Now it's going to ask me for a card name. Let's keep it easy. Let's say 2. Okay, our current count is 0 because we only increment count if our card, our value, is from 3 to 6 inclusive, right? So if I did 3, count is 1, right? If I did 6, count is 2. 7 should not increment, right? If I said 10, I should drop 1. If I said 11, I should get an invalid error. Now let's say this. Let's say I had 1, right? That's also not a valid card. But if I did A, K, J, right? I'm starting to get into negative count. If I did 4, 3, 3, 3, okay, that's great. Okay, but what happens if I did X? What should happen? I exit the program. It's a clean exit, right? We don't display the count. We don't do anything with our count. We just cleanly exit because we defined a flag here initially to set it to is playing true, and we have our while loop here that is constantly going to run. So as long as that is playing flag is truthy, we call it truthy because 1, 2, 3, 4, those are all considered to be true, right? And we only set our is playing flag to 0 if our input is X, right? And when we set is playing to 0, we immediately skip the rest of the iteration and go to the next iteration by using our continue statement, going back up to the while loop, where we can actually then check again for the value in is playing. This time it's 0, so this loop actually does not execute. So I'll collapse that, goes to return 0, and our program exits. So that's great. I think chances are our answers are going to be different from the books. Okay, answers for that one exercise. Answers here. So So they did my first attempt where I checked for the first letter, right, of the string, right? That's a valid way to do it, but I just think it's kind of confusing because my tendency is to think it's like, oh, I declared a string, right? But I never gave it any value anyway. It's kind of weird for me to like kind of check for that, even though I haven't assigned anything to it yet. So, but otherwise, they use continue here because I think they want to still execute the program. Like they still want to allow you to play, right? For me, we just chose a clean exit. Simple. Excuse me. Okay, so this is their test. All right. There are no dumb questions. I love these because it's a good Q&A, right? All right, so why do I need to compile C? Other languages like JavaScript aren't compiled, are they? Well, C is compiled to make the code fast. Even though there are languages that aren't compiled, some of those, like JavaScript and Python, often use some sort of hidden compilation to improve their speed. Is C++ just another version of C? No, C++ was originally designed as an extension of C, but now it's a little more than that. C++ and Objective-C were both created to use object orientation with C. So I think, the takeaway here with this question and answer is that C is not object oriented. There's no like concept of like constructors and classes and inheritance and all that other stuff you would find in other languages. They kind of don't exist in C. I say kind of because you can kind of still design your program in a way that kind of mimics it, right? So here we go. What's object orientation? Well, we learn it in this book. Object orientation is a technique to deal with complexity. We won't specifically look at it in this book, which I think is really good because it's a bigger topic and requires a lot of experience in terms of projects to kind of be able to appreciate. So it's for us right now, like for a noob like me trying to learn all this, like I just feel that that'd be too much information. So C looks a lot like JavaScript, Java, C Sharp, etc. Yes, C has a very compact syntax and it's influenced many languages. What does GCC stand for? The GNU Compiler Collection. Why collection? Is there more than one? Yes, again, the GNU Compiler Collection can be used to compile many languages, though C is probably still the language with which it's used most frequently. True, because that's how I know what GCC is. I didn't know it was for other things too. Can I create a loop that runs forever? Yes, if the condition on the loop is the value 1, then the loop will run forever. It's exactly what we did here, right? Is playing is 1, so then it was just constantly running. Let's just review that right now. Let's actually do this, right? Let's never assign is playing to 0. What would happen? First, we have to compile a program, then we'll run it, right? And we did X, 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 hey, okay, fine. That's not a valid card. We were expecting uppercase A. But really, what I'm trying to say is that, true, false, whatever is not really a thing. In C, it's more like truthy and falsy, right? So either 0 or non-zero. Non-zero being truthy. Okay. Is it a good idea to create a loop that runs forever? Sometimes an infinite loop or a loop that runs forever is often used in programs like network servers that perform one thing repeatedly until they are stopped. But most coders design loops so that they will stop sometime. Okay. Whew! It's a lot of information. But just real quick before we we're about to end the chapter, but I don't want to end it just yet. There's another type of loop that I don't think we actually really tried, and that's the for loop, right? A for loop is just like a while loop, except more compact. It contains three things inside itself: the initialization of that variable, the condition check, and then also the thing to increment things, right? So I'll just give you a very simple example here, and then I would just play around, right? Because we're gonna do a lot of for loops down the line, and I think I'll just be explaining them anyway. But just to get a sense, let's just create a quick loop that counts up to some sort of number, right? So I'll first make another project. Let's see what names I have available. Why am I even here? I can just do it through here, right? I like the GUI. So because Linux isn't always about command line, right? We're on desktop Linux, right? We want a good experience. We want less typing, so more clicking. We'll have something called for loops test. I'll probably get a lot of hate for saying that, but okay. So let's create a quick program that I'll show you what a for loop looks like. So we're going to do include stdio.h int main again, and then we'll have a for loop, right? First return 0. And this is more modern C, right? The way to do this. So we'll have a declaration where we start int I, right, equals to 0. So we'll initialize with an I variable to 0, and then we want to loop until this condition is met, right? Or until this condition. Yeah. Until this condition is met, meaning that this condition evaluates to false, right? So I'll just say 11. And I'll just say equal to 10, like this. It's easier to read. And then and this is the last part is actually what you do after each iteration. So in this case, I want to increment I by 1 after each iteration. So now print I in this case by providing a placeholder, right? That's about it, really. It's actually more compact than a while loop. Let's then go to our for loops test gcc main.c. Let's leave it as default. Oh, again, I did the print thing. Just say print f. All right, f. Okay, a dot out. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's the same thing. Same thing as a while loop, right? So we do our decorations inside this body here for 4, right? Again, it's kind of like a instruction for the computer to do, these 3 things on every single iteration inside the body, right? So it's like, okay, well, like at the start of every loop, declare this variable here. Okay, now execute the body, right? So if I is now 0, so we'll print 0. Okay, we're done with the iteration, right? Because we're done with this body. We go back up, then we check here on this middle part. Well, is I less than... Wait, we don't. We increment first. we increment first. After we're done with this body, right, in the for loop, we'll go back up, we'll increment. So now I is going to be 1, right? And then the computer is going to go, well, is I less than or equal to 10? In this case, it's not, because I is 1. 1 is less than or equal to 10. That's cool. So now what's going to happen is that the computer is going to execute the body of the loop again, right? This time printing 1, right? So we print 1. We're going to then exit the body, but then go back up here and increment I again. This time going from 1 to 2. Okay, should we execute the loop again? Well, that's where the computer actually then comes back to here, this condition check, and checks to see if we can execute the loop again, or the body of the loop again, right? In this case, 2 is less than or equals to 10. That is true. So then the computer will execute the body of the loop once more. Print 2, right? Okay, so now it's done. It has nothing more to do. Goes back up and checks and does the increment again, right? and this time going from 2 to 3, and before it needs to before it tries to execute the body, right? It's going to check the condition again to see if it's true, meaning that if it's allowed to. So this time 3 is less than or equal to 10, right? So yes, the condition, right, it's met. And so we actually just keep executing the body until we have I is 11. And then when it finally goes up again and checks, well, is I less than or equal to 10? I being 11, is 11 less than or equal to 10? Then that turns out to be false, so we don't execute anything. We skip that, and then we go to the next line. Right here, we return 0. Ooh, mouthful. I was trying to speak as fast as possible, so it was kind of not that great, but I think if you were to trace it, you get the idea. By the way, I recommend adding print statements here and there. Just try to see things. Don't eat this. Okay, so we finished our first chapter. I've survived. I've survived the first chapter of C. I think I'm gonna leave it here for today. So we learned a little bit more about loops, and functions, a little bit about functions. Yeah, actually, why don't we do this? Why don't we just play around with strings a little bit and create a project, right? A simple project. It's silly. Like you would never do this in real life, but I kind of just want to show you um uh command line arguments, right? I want to show you how you can actually pass in arguments to your C program and actually display them. Because remember I said that like your main function here actually can take in arguments. That that's actually those arguments, those command line arguments, right? So like how like we're always doing this GCC main.c, right? Like GCC is the program and main.c is the arguments, right? And so I think we can make a program that does something like this. Let's try it. So let's create a new project. We'll call it arguments, right? And we'll have main.c. Again, include sdio.h, right? And we'll just quickly write our skeleton, our usual skeleton. Okay? And our goal for this program is to receive some command line arguments and just print it out, right? Now in C, I believe the syntax here is going to be something like this. Int arg C, right? Character, an array of characters, or like a double array of characters, but it's normally written like this. I think it's like this, right? Argc is going to hold so this is a special like signature. Basically, whenever the your I guess your operating system or whatever executes your program, right? You know how I said that your operating system is always going to look for the main function, right, in every C program. It's going to pass in, right, the number of arguments or like command line arguments that was also like typed to execute your program, and also the specific strings themselves corresponding to those arguments, right? So let's say this, like in this case, you have GCC main.c, right? You would technically I think the argc, right? The number of arguments would be 2. GCC is considered like the program itself is considered to be 1, and then you'll have main.c, which is 2, and then inside this like uh-oh. Okay. Hello. Weird. Oh no! It restarted because I did have this little icon up here that was telling me to restart, and it was literally warning me. It's like your computer's gonna restart anytime soon. Ah, okay. Well, it's okay. We're still here. Okay. I think it just did that on me. I don't know. Something happened, but okay. Where are we? CD or CD code. CD average dev. CD projects. C. CD arguments. Okay, so you know how we had like this, right? We're executing our program gcc main.c, right? So I said that this is like the number of arguments, command line parameters. So it's 1, 2. Like there would be 2 here, and this is actually an array of strings, right? The reason, don't mind this star yet. There's like what we call pointer. Actually, it looks more like this. I think it's more like this. Oh no, isn't okay. I don't care. Okay. Oh, what's going on? I guess it's trying to send system information or something. I don't want to report it. Okay. Okay. So this is an array, like D message. Okay. Okay. That's why you don't run Ubuntu 24. Okay. All right. I think it's also trying to update too or something. Ah, that's right. Okay. No, not now. Okay, so don't mind this star here. We're gonna learn about it on the next chapter, right? But for now, just take this argv and treat it as if it was an array of strings, meaning that the first index is one string, the second index is another string, and so on, right? So then basically this argv is going to have the tokens, right, separated by space. So be I think in one element is going to be GCC, and then the next one is going to be main.c, something like this. So that's an example, right? Again, I'm just trying to remember what I learned in school. Like that was like over a long time ago, more than 15 years ago when I first learned this, I think. Yeah, okay. So I think it's at 15. So let's just actually print stuff out, right? Let's say I want to know the number of arguments, right? The number of arguments. And we'll just print out argc. I'm pretty sure this is how it's done. And I'll print out, let's say, the first. No, let's use loop skills. Let's use loop skills. Let's print out every single argument. Because we know argc is the total number of arguments, right? So we can just do this. Int I, right? For int I equals 0, right? That's our index, right? We can just say index. Arg index, right? Arg idx, right? Arg idx, we're going to execute this while arg idx is less than argc, right? Which is the total number of arguments, and then we'll just increment arg index by 1, right? Maybe this might work. I don't know. So printf, right? The current value, right? And it's a string, right? It's a string. Let's see. At index, maybe do this, %d, right? So we'll have arg index. Then we'll have argv at that, we'll access that string itself, right? So then, not I, arg index, right? So let's break this down so it's a little clearer. Right. So we'll have three things to our printf. So we'll have the current value at the specific index, which is arg index, and it will display the string at that index. Let's see what happens. So let's compile. GCC main.c, right? We'll have a.out, right? And we'll have one argument the current value at index 0 is a.outs, because that's what we passed in, right? But what happens if we say this? Hello world. We have 3 arguments. And now, the current value at index 0 is a.out. The current value at 1 is hello. The current value at 2 is world. Interesting. So how about if we do this? Hello world with quotes. Ooh. Number of arguments is now 2. Huh. The current value at index 0 is a.out. And the current value at index 1 is hello world with the quotes. This works just like all command line programs in Linux. If you want the space to be treated as not a delimiter to your command line arguments, you always wrap it around quotes. So essentially, we can recreate echo, right? So let's recreate echo using this information, right? Our echo program is going to be simple. We are only going to echo the first value after the after our program argument, right? So in this case, at index 1, we're only going to print out whatever's in index 1, right? So let's create a new project, right? Knowing this information, we'll call it, I don't know, echo clone, right? No, how about we call it, to our branding, average echo. Let's call it average echo. So we'll have a main.c. Again, include stdio.h, right? And we'll declare main method, or main, ooh, calm down, not a method, a function, okay? And this time, we're gonna take in some arguments, right? Okay, return 0. So we just simply want to, right? In this case, let me demonstrate echo. This is not our program. This is the built-in echo for Linux. We did hello, we'll get hello, right? Hello world, we'll get this. But if we did hello world, we'll get hello world all like that too, right? But I'm going to keep things simple. We're just going to echo out the first value, right? And then we'll expand from there. Okay. So, back up. Okay, so now we need to check, right? We only want one value. So if there's like, that means argc has to be what? Argc has to be 2, right? First, right, the very first element is going to be the name of our program. And the second one is going to be the thing that the value we want to print out as like an echo, right? So let's not do anything if we get less than 2 in argc. If we get less than 2 values in our command line parameters, we don't want to do anything, right? Because we don't have a value to print out in this case, right? Because if argc is 1, we don't have that second value. It's going to be just like this, right? There's nothing, right? I mean, we could just display a new line. We could do that too. You know what? Let's just do it, right? So if argc, right, is less than 2, because we need minimum 2, we'll just print a new line. And then we'll just call it quits. Okay? Otherwise, we're going to get the first value, right? First, this is a value, right? And not a character, but an array, right? I'm not sure if this will work, but let's see. argv at 1, right? And now we want to just print that. Simply print it with a new line value. Okay? I'm trying to avoid the use of like pointers, you know, it's like so that's why I'm trying to rewrite things as like only using arrays, for those who already know all this. So and I'm not skilled enough to know the difference yet. All right, so I'm going to compile, right? I'm gonna run it. So wait, oh, this is the wrong one. Oops. This will be the last program today. I'm getting tired. So um, average echo. So GCC. Okay, so we can't do that, right? Error, invalid, initializer, right? So we can't just access it like that. I think it has to be something like this. Yeah, just take it for what it is. Yeah. So a dot out, right? Let's compile it to something else. Let's remove a dot out, right? Let's actually compile it to something called a echo, right? Average echo, right? So let's do that. So clear, we do a echo. Oops, a echo, get nothing, right? A echo, hello world, right? We'll get hello world, right? If we do a echo, hello world, we should just get hello because again, our requirement was to only print out the first value after our program name, right? So in this case, if we didn't wrap anything with quotes, anything that's delimited by spaces is considered a separate value. Yeah, so that's how kind of echo is implemented in a nutshell, right? Like, I mean, just by observing like what echo does normally. I mean, there's other cases too, like where you can like echo out, like for example, shell variables. I wonder if our program does that. Let's find something out about Linux or at least Bash. Let's see what comes first. The substitution of the environment variable and then using that value in that environment variable and passing it into a program, or having our program actually evaluate the environment variable and then doing something with it. Basically, what I'm trying to say is, are we responsible for the environment variable, or do we get that for free? Oops. Looks like we get it for free. It looks like every time when you run something in Bash, right, the environment variable gets evaluated first to end up looking something like this, and then it runs the program, right? So that's cool to know. All right, so it's like a substitution. It substitutes first, and then it runs your program. So, um, yeah, that's all I had today. Yeah, we'll try and go get to pointers maybe next time. That's gonna be it's gonna be a tricky one. I'm still trying to master them myself. I don't even consider myself a master. I'm just trying to get familiar still, and hopefully I can explain what I know next time. Bye.